Okay, so we are going to keep working in the Unit 3 packet. We're going to skip page 3 and move to page 4. So on this lesson, we are going to solve for the remaining sides and angles of the given triangle. So when you are solving a right triangle, you're trying to find all of the sides and angles that you don't know. So you'll be given 3 and you have to find 3. Now, this is something that's heavily tested on the challenge exam without the calculator. So we are going to write the expression that we get without the calculator in the first blank and then use the calculator to approximate to 2 decimal points in the second blank. All right, so on the first thing we're going to do in all of these is just go ahead and draw a right triangle. And we're going to label it ABC. Now C has to be the right angle because it's one that's 90 degrees. And the way that sides and angles work on triangles, the way that you label them, so we know that side C is 14, so it needs to be opposite of angle C. And then side A is opposite of angle A, and side B is opposite of angle B. All right, so we are going to, we can find angle B pretty easy just using geometry. So if one of the angles of a triangle is 90 degrees and you know the other one, you just do 90 minus 21. You could do 180 minus 90 minus 21, but it's quicker when you have a right triangle to just do 90 minus 21. All right, so that's 1 down, 2 to go. And then if we want to find side A, and we know, oh, let me label this angle. A was 21 degrees. All right, we know this angle, and we know this hypotenuse. The trig ratio that relates side A and the hypotenuse to angle 21 is going to be the sine. So we would say the sine of 21 degrees is equal to the opposite over the hypotenuse. And if you guys watch the Getting Tricky with It video, which I think is kind of funny and very educational, it says something when the variable is up high, you're going to multiply. So that's what we're going to do. The variable is up high, A is up high, so we're going to multiply. So A should be equal to 14 times the sine of 21 degrees. That's what we would write in this blank. All right, and then we now want to find side B. All right, so you look at what you want and look at what you have and think about the trig ratio that relates those. And so that's going to be cosine of 21 is equal to the adjacent over the hypotenuse. And then again, because the variable is up high, you're going to multiply. All right, so we go to our calculator. Now my calculator, I don't have the 84. This is like the calculate 84 or something. It does everything you need, but you need to make sure you're in degree mode. So change your calculator to degree mode if you need to. All right, and then it's just going to be 14 sine of 21. So that leg is going to be 5.02, and then 14 cosine of 21. Another one's going to be 13.07. Now, I like for us to actually find the value instead of just the expression, but on the actual challenge exam, what you need to know are these 2 things. They're not going to have you figure out the decimal on that test because you won't be able to. Okay, Example 10 is similar, except instead of given an angle and the hypotenuse, it's an angle and a leg. All right, so we'll draw our right triangle. We have ABC. So we know side A. Sorry, my dog just dropped a ball right beside me. All right, so same process. We can find B by subtracting 77.2 degrees from 90 degrees. All right, then we can find side B by using trigonometry. So we want side B. Right. We know this angle and this side. So think about what trig ratio relates them. And that's going to be the tangent. So the tangent of 77.2 degrees is going to be the opposite over the adjacent. Right, and then if you watch the video, he said if the variable is down low, you're going to switch, right? Mine said x. Right, and that's what we'll do. Since our variable is in the denominator, we're going to switch. So put b where the tangent is, and then put tangent where the b is. Okay, so that's what we'll write in the blank. All right. And the other thing we need to find is side C. Okay, so look at what you know and look at what you want and think about the trig ratio that relates those, and it's going to be the sine. So the sine of 77.2 degrees is the opposite over the hypotenuse. And then the variable is down low, so you're going to switch, So C should be 20 divided by the sine of 77.2 degrees. Yeah, the wrong button. Okay, so and we're still in degree mode, so we don't need to worry about that. So we get 6.70 for B. And 30.252. Oh, I typed that wrong. There you go, 30.25. And again, the smallest angle and smallest sides go together, and largest and the middle go together. All right, on 11 and 12, we are not given an angle except for the 90-degree angle. And so these are going to be a little different. We're still going to use trig ratios, but slightly different because we're going to be looking for an angle using trigonometry. So if I want to find angle A, and then I look at what I know, what relates those together is going to be the tangents. So the tangent of A should be the opposite. I'm just kidding. It's the hypotenuse. So the sine of A is going to be the opposite over the hypotenuse. All right, then if we know what the sine is, and we want to find what angle has that sine, that's when you do the inverse trig ratios or the arc sine. So the anytime you have sine to the -1, it's going to give you an angle that has that sign. Okay, so that's what we'll write in the blank for A. The inverse sine of 8/13. Right, and then we will do the same thing, but finding angle B. Okay, and if you're looking at those sides of the triangle with that angle, the relationship is going to be the cosine. So the cosine of B is equal to the adjacent over the hypotenuse. So we want to find what angle has that cosine. We'll do the inverse cosine of that fraction. And let's type it in. So inverse trig functions is second, and then the number, or then the button. Okay, and as long as your calculator is in degrees, that will give you an angle in degrees also. Okay, those are our A and B angles. All right, and then to find the side B, we don't have to use trigonometry. We can just use Pythagorean Theorem. All right, and since we know the hypotenuse is going to be the hypotenuse squared minus the other leg squared, that's going to be 105. And then you can find the square root of 105 by hitting second and then x squared to get square root. 10.25. Okay, one more to go. Very similar, but instead of given a leg and hypotenuse, we're going to have two legs. Oh, and we are given units. One is feet and one is inches. We don't want that, so we'll make them both inches. All right, so let's start with angle A. Here we know the opposite and we know the adjacent, so that means we're going to use the tangent. So the tangent of A is going to be the opposite over the adjacent. So A is going to be whatever angle has that tangent. So we can find it by doing the inverse tangent. Okay, and then we'll do the same thing with B. Okay, looks like we're still going to have to do tangent. So the tangent in B is going to be its opposite, which is 15, over its hypotenuse. No, it's adjacent, which is 24. Okay. You just type that in. Okay. And then finally, to find C, we are going to use Pythagorean theorem, but this time, since we're looking for the hypotenuse, we are going to add. And then the square root of 801 is 28.30 inches. Okay, so what I want you guys to do is turn to page 8 and 9 in this packet. And I want you to do a number 2, which is going to be A through G. And then next lesson, we'll start talking about some applications of right triangles.